We are going to keep working in chapter 8. Reminder that we're meeting today. Do not come on Thursday because you can work on your test and give me the day off for that. It is due on Monday. And remember, it's a shorter one. It's only worth 50 points. I think it's like maybe 19 questions. Whatever it was, it's less questions than the last one was. So we only covered, I want to say it was like 4 or 5 sections. So it was less material. So less that you have to worry about for this exam. But we are going to continue with probability in chapter 8 here. And we have kind of talked about these already. We've talked about whether we have sets with overlap. So we're just going to kind of review them again. So disjoint means that whatever 2 sets you're working with, they are completely separate from each other. Versus not disjoint is when they had a form of overlap. They have pieces in common, and the way we worked with these was just a little bit different. So when we did our set counting, if it was A or B, I just added what was A, added to what was in B, versus the other one, we did A plus B minus the overlap, because the overlap counts those pieces twice. So remembering that A intersect B is in the middle there. A union B is anything in A, anything in the overlap, as well as anything in B. So anything contained in the circles. Okay, so remember, disjoint means no intersection. Not disjoint means they're going to have overlap or intersect. All right, on the next slide here, I'm going to give you probability formulas. We've already talked about like how we add them all together. Now we're going to see similar in probability form. So if I want a union for any 2 events, this one up here is called the general addition form. If you remember from statistics, this is the equation that was called the general addition form in the book that we used. So if I want to find the probability that A or B happens, I take the probability that A happens plus the probability that B happens, and then I subtract the intersection, the probability that they intersect. If they are completely separate, mutually exclusive events, disjoint events, to find the probability of A or B, or A union B, it is just the probability of A plus the probability of B. So if there is no overlap, you don't have to subtract out the overlap. And then the probability that we get a complement. So if I know the probability of E, that is 1 minus the probability of E naught, or E's complement. Or if I want to find the probability of E complement, I take 1 minus the probability of E. So it works either way. I can either find the probability of E if I know E complement, or E complement if I know E. Just subtract it from 1. We are going to look at different scenarios and answer a bunch of probability questions. So go ahead and write our scenario down. We have a container that has 9 red balls, 6 green balls, and 10 white balls. what we are going to be doing is drawing a single ball from the container at random. So I have 9 red, 6 green, 10 white. Anytime I come across a real world situation, I always want to get the total. So that is going to be 1925. I need to have the total before I can do any of my probability questions. The first question then says, find the probability that the ball is red. So the way I write that, I put a P, capital P, and then in parentheses, I put what I'm looking for. So I'm looking for red. So the way I write that, probability of red is equal to, and then this is just a basic probability. How many are red out of how many total? Well, there's 9 red out of 25. If you can reduce, you do so. If you can't, you just leave it like that. This one doesn't reduce, so I'm just going to leave it as 9 out of 25. The next question says, what is the probability that I get green or white? So remembering, if I go back here, this is the or stands for union. So what I need to do is I need to say, okay, are these events with overlap or are they completely separate? Well, these are completely separate colors. I can't draw a green and a white at the same time, so I'm just going to add their individual pieces together. So probability of green plus probability of white is what I need to do. We have 6 green out of 25, and we have 10 white out of 25. So if I take 6 out of 25 and add that to 10 out of 25, I get a total of 16 out of 25. Hopefully this is review for you guys. The ball is red or green. So P, red, union, green. Again, these are completely distinct, disjoint, mutually exclusive events. They cannot happen at the same time. So I'm going to find the probability of red and add it to the probability of green. Red was 9 out of 25. So that should be a plus sign. Green was 6 out of 25. And if I add those two together, that's 15 out of 25. This one I can reduce. Both 15 and 25 are divisible by 5. So if I do that, 3/5 would be the final answer. Next one asks the probability the ball is not white. So this is asking for the probability of white complement. So that's where you put that little apostrophe, and we don't want white. So this is found 1 minus the probability of white. Well, white was 10 out of 25. So 1 minus 10 out of 25. If I've used 10 out of 25, how many are left? 15 out of 25, which is the same one back here, right? If it's not white, it has to be red or green. So it should be that 15 out of 25 or that 3/5. So next one, probability the ball is not green. So green's complement. So 1 minus the probability of green. Green was 6 out of 25. So 1 minus 6 out of 25 leaves me with 19 out of 25. And then the last complement we have here, the ball is not red. So P, probability of red complement, 1 minus the probability of red. Red is 9 out of 25, so 1 minus 9 out of 25. If it's not red, it has to be green or white, which is this guy up here. 16 out of 25. We are going to work with 2 dice here. It says an experiment consists of rolling 2 fair dice and adding the dots on the 2 sides facing up. Compute the probability of the following. So we're rolling 2 dice and our goal is to find probabilities of different sums. Anytime I ask you a question like this, feel free to go back to this table. So our first one here, go to my highlighter here, says the sum is 5. In the 2 dice table, every sum is found along a diagonal. So here's the sum of 2. This next diagonal is the sum of 3, then the sum of 4s, then the sum of 5. 4 plus 1, 3 plus 2, 2 plus 3, 1 plus 4. So I've highlighted 4 of my options. Well, how many are there total? Well, we have 6 rows or 6 options for the first die times 6 columns or 6 options for the second die for a total of 36. Now these are both even and actually both divisible by 4. So I can reduce this one because 36 divided by 4 is 9 and 4 divided by 4 is 1. So final answer, you have a 1/9 chance of getting a sum of 5. I'm going to do C next just because it pairs with what we just found. It says the sum is not 5, meaning I want the complement. So P of 5 not means I'm going to take what's left. 1 minus 1/9. If 1/9 of the values are a sum of 5, the remaining 8/9 are not a sum of 5. Next one, the sum is 8. So that's 5, 6, 7. Here's the sum of 8. I'm just going to follow up my diagonal. And this time I highlighted 5 options out of my 36. 5 and 36 does not reduce, so I'm going to stop there. And then I can find the sum is not 8 by taking what's left. So 1 minus 5 out of 36. If I've used 5 of the 36, there are 31 of the 36 remaining. The sum is 7 or 11. So or means I'm just going to add them all together. So here's my sums of 7. 6 and 1, 5 and 2, 4 and 3, 3 and 4, 2 and 5, 1 and 6. 11 is made with 6 and 5 or 5 and 6. So for this one, I have done 1, 2, 3, 4, 5, 6, 7, 8 of the 36 options are accounted for. And divide them both by 4, 2/9 is the simplified form. Right. F says the sum is 7 and 11. We have to think about what we're doing here. We are picking up a pair of dice and rolling it one time. Is it possible in a roll to get both a sum of 7 and 11 at the exact same time? No, okay, not possible. I cannot do this, so the probability is 0. I am only rolling the die one time, so that cannot happen. Next one says the sum is divisible by 3 or 4. So before I go and start highlighting here, what numbers can I divide by 3? What numbers can I divide by 4 that are going to be sums? Let's see, our lowest sum is 2, our highest sum is 12. So what numbers between 2 and 12 can you either divide by 3 or 4? 3. 3 is divisible by 3. Give me another number. 4. 4 is divisible by 4. Give me another number. 6 is divisible by 3. Good. 8 is divisible by 4. 9 is divisible by 3. And then 12 is actually divisible by both of them. All right, so now I'm going to highlight all of those. So 3, 4, 6, 8, 9, and 12. All right, how many is that? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20 of them out of my 36. And then again, I can divide by 4. So 20 divided by 20 divided by 4 is 5. 36 divided by 4 is 9. All right, the last one says the sum is divisible by 3 and 4. So these are the numbers back here that are divisible by 3 or 4. 3 was divisible by 3, 4 was divisible by 4. Neither of those are divisible by both numbers. 6 is divisible only by 3, 8 is divisible only by 4, 9 is divisible only by 3, but 12 is divisible by both numbers, correct? 12 I can divide by 3 and 12 I can divide by 4. So the only sum that's divisible by both numbers is 12. And that only occurs 1 out of 36 times. So and means they have to happen simultaneously. The only way the number is both divisible by 3 and 4 is if your sum is 12. This one, you can't happen simultaneously, therefore it was 0. This is a two-way table, meaning we have variables that are rows and variables that are columns. In this problem, a survey was taken at a local college campus. The survey asked if the student was full-time or part-time, and then asked their work schedule. So either they did not work, they worked part-time, or they worked full-time. So each student had to answer 2 questions, and then they fell in the corresponding box. Now, generally when I have a two-way table, I just like to highlight everything that is a part of my answer and add it all together. Want to find the probability that the student is full-time or works part-time. So this is generally what I do. So full-time students are here in this row. Or works part-time. Part-time is this column. So what I need to do is I need to sum all of those values together to get the probability of full-time student or working part-time. If I add all of those together, 9, 10, 2, carry the 1, 2, 4, 5, 6, 7.72 is going to be my total for that one. And you want to make sure you're reading carefully. When it's an or, you're going to add all of them together. This next one says and. And means they're happening at the same time. So he or she is a full-time student and works part-time. So I want to find a full-time student that is also working part-time. Full-time student working part-time is only this value, 0.22. Okay, both parts have to happen at the same time. So it has to be in that row and that column where they overlap. All right, next one says he or she is a part-time student. Okay, so part-time is here. Or does not work. So or means I'm going to add that additional piece over here. So 0.09, 0.21, 0.19, and 0.15. 0.64. When I read the next one, it says he or she is a part-time student and does not work. So they have to be part-time and also not work. So part-time, not workers are right here, 0.09. Next one's another and. So he or she is a full-time student and does not work. So full-time does not work is right here, 0.15. And then our last question is an or question. He or she is a part-time student or works full-time. So part-time student is down here. Works full-time also combines that one in there. So 0.09, 0.21, 0.19, 0.14. 1923, 2, 3, 4, 5, 6, 0.63. I show you the way that I like to do it, just because this table doesn't have totals. If the table had a total column and a total row, we could use the formulas that we got at the very beginning. So let me sum these really quick. 0.51, I mean, that's going to be 0.49. 1, 5, and 24. 43. And 23. For any of these or questions, the other way I could have done this, I'm just going to erase this out for a second. So let's say, so full-time or part-time. So full-time student is that value 0.51. Probability of full or works part-time. So I can take the probability of full, 0.51, plus the probability of worked part-time. That is this one, 0.43. And then you can see how I have a column and a row and how they intersect, they overlap at this value. That would be subtracted out. And if I take 0.51 plus 0.43 and then subtract out 0.22, I get that same 0.72 that I got back here. So you have an option of, do you want to use the formula Or do you just want to sum up all the values that you're counting out of the whole box? Either one will get you to the same answer. This is going to be another two-way table, except for that it gives it to me in word problem form. So I'm going to create my table from my information. A class is made up of 7 male and 3 female seniors. Okay, so I have a male and female that are seniors. 7 male, 3 female. 2 male and 5 female juniors. I'll write those down. And 2 male and 6 female sophomores. So let's see, my total is 10, 17, 18, 19, 25. If one person from the class is picked at random to serve on an advisory committee, what is the probability of the following? So A says choose a male or a junior. So I want any of the males as well as the juniors. So if I add those together, 7, 9, 10, 11, 16 out of the 25. Next one says choosing a female sophomore. So the sophomore has to be from the female column, and that is 6 female sophomores, so 6 out of 25. The probability of not getting a senior. So here again, is this, I could use the formula, or I could just sum up what I don't want. So there are 10 seniors. So I could do 1 minus 10 out of 25, leaving me with 15 out of 25. Or I could have said, well, if I don't want a senior, that means I can choose juniors or sophomores. And if I add those together, that's 7 plus 8, 15 out of 25. So it's really just preference of how you like to do them. Next one, probability of not choosing a male. So I don't want the males. I could do 1 minus the probability of a male, or I could just count up all the females. That's going to equal the probability of getting females, right? So 3, 5, 8, 8 and 6 is 14 out of 25. Probability of choosing a female or a sophomore. So here's my females, but I also want to combine all my sophomores together. So 3 and 5 is 8 plus 6 is 14 plus 2 more is 16 out of 25. And the last one on here, choosing a senior or a female. So here's seniors, here's females, add them all together. That's 10 plus 11, so 21 out of the 25. We are also going to talk about the concept of odds. So probability is the number of successes over the total number of possibilities. Okay? Odds are going to be the number of successes over the number of failures. So if we talk about using odds versus probability here. So if I talk about rolling a 2, so I'm going to go back to probability here for a second. The probability that I roll a 2 is there's one way to roll a 2 out of a total of 6 potential sides. Okay? Odds want you to take how many ways you get it versus how many ways you don't. So I can roll a 2 one way, and then there's 5 remaining numbers. So the odds are going to be 1 to 5. Generally speaking, odds are written with the colon between them versus the fraction bar, but either one will still work. So odds of rolling a 2, there is one way to roll a 2, 5 ways not to roll a 2. The odds of not rolling a 2, well, there's 5 ways to not roll a 2 compared to one way that does roll a 2. So here's how we can work between them. If I have probability, I can go to odds. If I have odds, I can go back to probability. So let's take a look at this problem here. It says a candidate for mayor of a small town predicts that he has a 75% chance of winning the election. That's the probability. His probability is 75 out of 100. 75% is 75 out of 100. What is then the probability that he will lose? If he has a 75% chance of winning, what's the probability he loses? 25% is what's left. Now, we want to go the other way and say, what are the odds that he will win? So I want to put win over loss. Well, win is 75. Loss is 25. 75 over 25 is 3 over 1. So 3 over 1, 3 to 1 odds. If I want to find the odds that he loses, that's going to be the other way. So loss to win, 25 to 75, or 1 to 3. You're just flip-flopping the order of which one was first. If odds are A over B, then the probability of that event is A over A plus B. So if the odds of some event are 4 to 7, I can go to the probability. So if this is the number of successes, 4, 7 is the number of failures. If I want probability, that's successes over total. So there's 4 successes over a total of 4 plus 7, 11. So probability and odds are related to each other. It's just a matter of, are you comparing successes to total or successes to failures? I have 3 application problems, and then we will be done for today. From a survey involving 1,000 university students, a market research company found 750 students owned laptops, 450 owned cars, and 350 owned cars and laptops. If a university student is selected at random, what is the empirical probability of the following? So this is actually going to go back to what we did in chapter 7. We're going to draw our Venn diagram, fill in our totals so that we can then find our probabilities. So laptop, car, both are in the middle, and we always start with the both. 350 is both. And then I'm going to work my way backwards. 450 own cars, but I've already put 350 in that circle. So there's 100 that own car only. Laptop owners were 750, already counted for 350. So that leaves 400 there. Now we've got, let's see, 400, 350, oops, and 100. I want to add all of them together. That gets me to 850. I need to get to a total of 1,000, which means there's 150 remaining outside of the circles, but inside of the box. We want to find probability they own a car or a laptop. So they can be contained in the circles. That's a total of 850. Out of the 1,000. So you could either write that as, let's see, 85 out of 100. I could just write this as 85% if I wanted to, just because I know 85 out of 100 is 85%. I could write it as 0.85. Or I could reduce that down. 85 out of 100, they're both divisible by 5. 85 divided by 5, 17 out of 20. So any of those are fine. Part B says they own neither a car nor a laptop. So they can't own a laptop, they can't own a car. That's what's outside here. 150 out of 1,000 leaves 15 out of 100, or 15%, or 0.15. Or if I counted for 17 out of 20, that leaves 3 out of 20 not contained in circles. So basically the same stuff we did before. It's just that when we did them before, we said, how many were this? We did like the number of laptop or computer, right? And we added those and we said it was 850. The only thing I'm doing now is saying I want the probability of laptop or car. So that's now 850 out of the total. We've just taken it one additional step. We have another two-way table here talking about how many miles the person drives and if they have or have not had an accident. So this is from an insurance company. By examining the driving records of city drivers, an insurance company has determined the following probabilities. So what's here is already probabilities. And if you look, this one gives me the totals. Generally, when I have the totals, I default to the formula because to me, that's faster then. So let's see. First question says, the probability that he or she drives less than 10,000 or has an accident. So less than 10,000 is this column. So there's my total, 0.2. Or has an accident. Accident is this row here, 0.3. But when I pair a row and a column, there is an overlap. I have to subtract where these two overlap, and you should see it right there. So that's 0.45. So for me, it was faster to add 0.2 and 0.3 and take away 0.05 than it was to add the four numbers, oops, together. I worked with 3 instead of 4, just preference. Next one says, he or she drives 10,000 or more miles per year and has no accidents. So they have to satisfy both of these pieces. It has to be 10,000 or more and not have an accident. Well, I look at this, and no accidents. So no accidents are down here, right? Only these last two occur driving 10,000 miles or more. I can't include this first one here because that's less than 10,000 miles. 0.2 plus 0.35 is going to give me 0.55, which is the complement to part A. In order to test a new drug for adverse reactions, the drug was administered to 1,000 test subjects with the following results. 60 reported their only adverse event was a loss of appetite. 90 reported their only adverse reaction was loss of sleep. And 800 reported no adverse reactions at all. The drug is released for general use. What is the empirical probability that a person using the drug will suffer loss of appetite and a loss of sleep? So, and implies the overlap, and that is the one value we do not have. When we're working with Venn diagrams, there are 4 values. Okay, so appetite, sleep. 60 lost their appetite, 90 lost sleep, 800 didn't have anything. So where are we at? 800, 60, and 90. 5, 1. We're at 950 out of our total 1,000. How many am I short? 50. Yep. So 50 is missing, and that is what goes in the overlap. So what's the probability of that? 50 out of 1,000. If I cancel out a 0, that's 5 out of 100, which is 1 out of 20. That's my probability. Or 5%, or 0.05, however you want to do it. Fraction, decimal, or percent all count as probability.